All right, this is the solution to FRQ number 7, part C. All right, so C says find the limit as x approaches -4 of f of x over x squared plus 4x. All right, so the first thing to do in a limit is to evaluate. And so I get f of -4 divided by -4 squared plus 4 times -4. All right, and so if we do that, f of -4, remember f is defined as that definite integral from -8 to x. So in this case, -8 to -4. So I could write the integral from -8 to -4 of g of t dt over 16 plus 4 times -4, so minus 16. All right, so I have this. Now, the integral from -8 to -4, right? So if I go here, integral from -8 to -4, remember, we already figured this out in part B, that the area here and the area here are the same, but one's below the x-axis, one's above. And so that area, very simple, is 0. All right, divided by, of course, 16 minus 16 is 0. So now, remember, when you evaluate a limit, you get 0 over 0. That tells you L'Hopital's rule applies. But what do you need to make sure that you state in order to use L'Hopital's rule? You want to state the limit as x approaches -4 of f of x is 0, and the limit as x approaches -4 of x squared plus 4x is 0, and f of x and x squared plus 4x are continuous and differentiable at x equals -4. How do you know that f of x is continuous and differentiable at x equals -4? Remember that this function, this graph here, is a graph of f prime. Is f prime defined at -4? And the answer is yes, there's a point there, right? And so since f prime is defined, that meant that f is differentiable. And remember, a function, if it is differentiable, if the derivative exists, it must have been continuous. All right, so now that that is true, we can use L'Hopital's rule, and we can say that the limit as x approaches -4 would be the derivative of the numerator, which is f prime of x, divided by the derivative of the denominator, which would be 2x plus 4. All right, and so then we would reevaluate. And so if I reevaluate, f prime of -4 over 2 times -4 plus 4. All right, and so now f prime of -4, remember, this graph is a graph of f prime. And so f prime of -4, very simple, would be 2. Right, and so we get 2 divided by 2 times -4, -8 plus 4. You could leave it like this, but of course you can simplify. Sorry, -8 plus 4. So you would get 2 over -4, or -1/2. Now, a common question is once I've used L'Hopital's rule, can I stop here? And the answer is no, because it is not immediately apparent. It's not obvious what f prime of -4 is, but you could stop here. All right, so that is part C.